Hello everyone, and welcome to a presentation on dimensional modeling, subtitled The Heart of the Data Warehouse. My name is Bryan Cafferky, and I'm a data solutions consultant and trainer with BPC Global Solutions. I'm also a Microsoft Cloud last year MVP and Data Platform MVP this year. I have decades of IT experience, and I'm the author of Pro PowerShell for Database Developers, published by APRESS, and also the leader of two technical groups, the Rhode Island Microsoft Business Intelligence User Group and the Southern New England User R, or R User Group. So if you're in the area, please consider joining those. And this is a bit of a different trend. I've been doing a lot of PowerShell lately, but I'm actually a data solutions expert and implementer, provider, and that type of thing. So I wanted to get back to my roots a little bit. It's been fun doing all the PowerShell, and I'll certainly do more of it. But I wanted to branch into other areas which I think are very relevant today. So what's ahead? We're going to take a look at, first, is dimensional modeling still a thing, and why it is. Then we'll discuss what dimensional modeling is, how it differs from relational modeling, dimensions, facts, the Star Schema, and the Snowflake schema. So why a data warehouse? Well, for one thing, data warehouses are all about consistency and quality of data. And if you have any kind of regulatory concerns, then you're going to want to make sure you've taken care of this, you've properly cleansed your data, matched and merged it, made sure it's as correct as you can possibly make it. Now, I've worked on a lot of data warehouses, and none of them are perfect, but there's usually a pretty high level of quality, and frankly, you know where your issues are. And when you're dealing with things, this big data where things are just kind of spun out very quickly, you probably don't even know what problems are in the data and if it's accurate. But that's one of the things when you're trying to spin things quickly. It's not a bad thing, but it's not designed to do what a warehouse is designed to do. And that's focus on your core business data, which is typically structured. We have a lot of information now about unstructured data, but structured data has been around for decades, and that's really usually the focus of a warehouse. So things like your financials, patient data for healthcare, order entry type of stuff. Orders like Amazon would be their orders and their financial related data to orders and things that people are getting. And related to that is governance. So the thing that you typically see with a warehouse is there's a conscious effort to document and administer the propagation and use of data throughout the enterprise. And that's really important because very often enterprises have the same term mean many different things to different parts of the business. And I've seen this a lot. One company I worked at had almost 10 different concepts of the idea, like location. Some would say it's a building. Some would say it's a specific address. Others would say it's like a region or an area. And so governance would define, what does that really mean? What is it? What are we going to call it in our warehouse? It also has to gets to things like merging data from different systems. And I've done that a lot also, and a lot of times you find that the order entry data may not match perfectly with the financial data in, say, the general ledger or the invoicing data. So when you get these kind of disparate things, these discrepancies, warehouse solutions are designed to identify and reconcile those and make sure the data is verifiable, it's right. And that gets back to supportability. The data warehouse has people behind it, it's supported, it has processes that have been implemented and tested. And with that is usability, which means the warehouse has been thought out and hopefully designed well so that the business can easily access it. One of the challenges with some self-service tools that you see is the ability of the business to easily pull the data that they need out, to be able to cleanse it and to be able to prepare it for use. Warehouses take care of that all for you, so it's signed, sealed, and delivered to the end user. And also warehouses typically will keep track of historical data as the company needs it or the enterprise needs it. And that's critical because sometimes there's regulatory requirements about that, like patient data. Or sometimes you just want to be able to compare year over year, or maybe go back a few years and look at trends. Typically, if you're looking at the more dynamic big data solutions, they're looking at very timely things. We're looking at one type of thing we're trying to answer and throw it away afterwards. So warehouses are designed to do something much more long-term, more structured, and it's a much more central asset to an enterprise. So when is a warehouse not appropriate? Well, it's kind of when you don't want to use it is when it doesn't fit what a warehouse is good at. So unstructured data is usually not the type of thing you're going to want to try to use a warehouse for. You may be able to clean it up or aggregate data like web logs. You could try. But very often, if the data is truly unstructured, you're better off just trying to get what you need from it in a short-term study and maybe not bringing it to the warehouse. And this would be not core business types of things. Things like video footage, pictures, could be streaming on social media. Those are not typically good sources to put into a warehouse. Typically, when you're looking for short-term goals, you just want to get some study done, something that you need quickly, you want to get it done, and you're going to throw it away. Excuse me. You're going to throw it away. That's also not the ideal solution for a warehouse. If you're looking for extremely quick extensibility, there are a lot of agile methods and things, so I don't want to make it look like warehouses can't be modified quickly. It depends a lot on how well designed they are and if they're properly following dimensional modeling techniques to make it easier. But if you're looking for that quick kind of throwaway where it's quick to do that, then it may not be the best solution. But remember, when you do things that are very quick and on the fly, you end up with kind of spaghetti code and difficult to support solutions in the long run. And finally, if it's a silo-based solution, not enterprise-wide, but something's very narrow in its focus, it's probably not the right place for a warehouse. So yes, data warehouses are still relevant, and so is dimensional modeling. And before we get into the main topic, I want to point out two books that I really like and recommend. The one on the left is really the Bible of dimensional modeling, I would say, by Ralph Kimball. And you can get that. It's a very popular book. You see it in a lot of places. If you ever go into any data warehouse teams, you typically see that book. On the right-hand side is Agile Data Warehouse Design by Lawrence Core. And I really like that because once you understand what you're trying to do with the data warehouse, the right goal of design, the Agile Data Warehouse Design book gives you a good way to approach it. What questions should I be asking? How do I move towards a solution? And I want to contrast transactional databases, also known as OLTP, Online Transactional Processing. OLTP databases have a different design criteria in mind. First of all, OLTP is about performance, but the performance they focus on in an OLTP database is designed towards maintenance of data, quick in and out maintenance. Because when you're doing maintenance of data, you want to make sure that it's fast and it doesn't impact other people that may need to do maintenance. So if you think of like a website that's doing transactions, if it goes in and locks up a lot of data trying to do an update, it's going to cause a lot of problems for other people trying to update data. So one of the things that you do in an OLTP design is try to minimize locking. And locking is very often doing write locking. You're trying to update data, which is not necessarily true. In fact, it's only rarely true except for the update cycle in a warehouse. Also, you're only retrieving in a transactional system small sets of data typically. It's a customer coming in and updating their banking information, or maybe transferring a charge, or cashing a check, whatever it is. So it's very quick, small, and so it's a different kind of focus. And in an OLTP design, if you've heard of the laws of normalization, this is where you apply those laws. In a warehouse, you need to forget those laws. I'll say it again, you need to forget those laws. OLTP designers make the mistake of designing warehouses with the concepts of normalization, and it's unfortunate because it's the wrong focus. It's perfectly focused for transactional processing. And again, I kind of put in yellow at the bottom here. Focus is on the customers or the people entering data and not impacting them. And I've worked in companies and focused on database engineering where you need to get in and out quick. And you really got to watch locking and things like that. And it's a very different focus because, again, it's all about updating. And you don't want to duplicate data either because you want to make sure you update it correctly. You don't want to have conflicting balances and things. So you want to make sure it's all in one place. And that gets back to normalization. So what about reporting database design? We'll talk about dimensional modeling. That's where we're really going. Well, first of all, you got to realize that, generally speaking, a warehouse is a copy of transactional data, OLTP data. It's a copy, not the direct. It's not the source of record, which means it's not something you have to worry about the maintenance per se, because the real maintenance of the data is happening in the transaction system somewhere else, and you're pulling it in for reporting purposes. So the performance focus is about retrieving the data quickly. It's not about updates. Usually in a warehouse, you have some sort of a batch process that runs maybe overnight, maybe on weekends, and it's in some sort of a window where there's low activity or no activity on the warehouse, and you can do updates. But even if you need near real-time or even real-time updates, there are techniques in which you can still have a fairly lengthy or process on the batch side to update the data and then switch it around. So again, in a warehouse, your goal is really about the experience of the primary user, which in this case is people using, doing queries and reports. Locking is not an issue because you have that batch cycle typically, you update your data and you get out. And most people using it, there's usually one process updating, hopefully in a warehouse at a time. It's doing its main sync, we'll say. And large sets of data are typically retrieved in queries that users are using. And again, they're not really locking it for updates, they're just querying the data. And I say large sets because they're trying to get analysis, they're doing reports. It may very well be that they're looking at all of their data in a table, or maybe they're looking at a year's worth of sales. They're not looking at just one or two customers typically, so it's a different emphasis. And again, insert and update speed is not really a relevant thing because end users should not be inserting into your warehouse. Now that we've established that, I hope I've convinced you there is a place for dimensional modeling and for warehouses and where they fall and what the performance and what the design differences are between them. So let's talk about dimensional modeling. Dimensional modeling is a design technique for databases intended to support end-user queries in the data warehouse. So Ralph Kimball said that. It kind of summarizes what I've been saying with the design. And I think that's a pretty good statement. Let's take a closer look. So specifically, what are the features of dimensional modeling? Data maintenance performance is secondary, as we said. Data is denormalized as needed to support reporting. And you get a lot of fight from people who tend to come from the OLTP design side of things. When you talk about that, it's very important though. The resulting model reflects the kinds of questions the business wants to ask. So the idea is the model is not designed to reflect some sort of maintenance. It's designed to be optimal for people asking questions about the data. What's our sales this year? What's our sales this year over last year? So you organize the data correspondingly. And you may even create data that didn't exist in the OLTP data very often as part of that because you want to support reporting and maybe you need to translate codes and things like that that the OLTP system doesn't. Descriptive data like customer name and things like that are separated from things like quantity, such as order amount. And we're going to talk about that splitting. And there can be some confusion there, so I'll try to cover it as best I can. So dimensional modeling primarily consists of dimensions and facts. Those are the two types of entities we'll be discussing. So let's start with what a dimension is. A dimension, first of all, is going to be about 95% of all of your data. So that's the first thing might make it easy, at least in terms of columns, how many columns you have. A dimension describes business events. We have here like a sale of a product or an order or whatever. They're what people use to sort, group, and filter on. It's descriptive information, and it can be numeric, but typically it's often text-based. So when you think of a typical thing, in this case, we've got this slide here. We can see we have a store dimension, and there's a store description, a city, a state, zip code. All of these are attributes that describe something. In and of itself, it's information, but there's no quantity if you look at it. The only thing you could really do is count it. How many stores do we have? And the counting, a numeric number, that would be something different, a fact. But this in itself is just a dimension. So the next part is a fact. A fact is also called a measure, and it's actually better called a measure to avoid confusion. It's a measurable metric. It's a number that it's described by dimensions such as a sale amount. So if you think about it, if you had something like $50, somebody bought something for $50, the $50 is the fact. Anything describing that sale, where was the sale, who bought the product, what did they use to charge the product, did they pay cash, all those details, those are dimensions. There's very few facts typically in a database. I've even had cases where I was creating a warehouse where I really didn't have any fact per se, but I was trying to do, what I ended up doing was just putting a single number like 1 so I could summarize and count using the dimensions. So when you think about this, most of what you're going to see is dimension values and not so many facts. And I want to be careful here because I've had people ask me when they think of fact, it confuses them. They say, well, It was bought at that store. That's a fact. Yeah, but we're not talking about the fact in the traditional use of the term. We're talking about a dimensional modeling fact. And as I said, throw out the word fact if it confuses you. Think of it as a measure. Because you said it was bought at a store, that's a measure. It doesn't really make much sense, right? Well, a store's not a measure. The height of a person is a measure, but the hair color is not, right? So when we think about that, you get these metrics. It's metrics, things that are measurable numbers are typically facts. Everything else is a dimension. We can see here a sales fact. We have sales amount, unit price, discount. These are all numeric values. And the other thing you notice about the fact is the fact table points to all of the dimension entities and really will be tables in a relational database. So the time key points to a time dimension, product key points to a product dimension and a store dimension, and then the salesperson dimension, and then you just have your facts. Now, in spite of the fact that we don't have a lot of columns in the fact table, because it is the lowest level of detail of data, tends to be a lot of volume. It takes a lot of space. And you'll notice here that more than likely the keys here are going to take more space than the actual fact information. So let's look at a star schema. This is a kind of a picture of a basic star schema. And I want to be very careful here because the first time I saw a star schema, I said, yeah, that looks just like a relational model. See, I've got my sales fact, but that's really just my kind of detail of my order table, and I'm just pointing to other tables. Look more closely, and I'm going to talk about this because it's not an accurate view, but it's easy if you're used to, again, relational design to think that's what you're seeing. First of all, I want to point out something. Do you notice that there's only a single spoke going out? There's no layering here. You don't see, for instance, the salesperson with a link to a store, with a link to a region, which you would typically see in a relational database. Instead, you have a denormalized dimension in which the fact points directly to the dimension. Dimensions do not point to other dimensions. All right, so we can see here the sales fact has the sales amount, the unit price, the discount, and the units, and it points to a bunch of dimension tables, 4 dimension tables. And so we can query them, and the keys would join us to any of the tables we need at any point. The fact table has the measures, and the dimensions have things that describe what happened. It describes the event or the measure, if you like. So it kind of makes sense. If we have a sales amount, it might be at the lowest level of detail. This was an amount of this sale. We don't know anything in and of itself just by looking at it, but it's a very low level amount. But we could go to the salesperson and time dimension and the other dimensions and find out exactly what was happening. Where was that done? Who was it done? Who bought it? And we could then even aggregate and say, well, give me the total amounts for that store or for that salesperson. So the fact is typically is the lowest level of detail, and we're rolling it up and filtering by it. So some key points about a star schema. As I mentioned, dimensions relate directly to a fact table only. We'll talk about what happens when you don't do that and what that's called, but right now we're talking about the star schema, and that's the first thing you should remember if you're in an interview. If they say, well, what distinguishes a star schema? Just say dimensions relate only to the fact table. That's it, not to other dimensions. The dimensions are denormalized. So the idea is if you have a region table in an OLTP, you typically say, well, I'll have a salesperson one table, and then I'll have a region table. I might even have a county table. And I could have any number of a product table, and then a product type table, and a product category table. That's an OLTP thing where you kind of splinter off things so that everything is discrete. That's normalization. We don't do that in dimensional modeling. In fact, we do the opposite. We could very easily merge salesperson with store, with region, with country if we want, if it makes it easier to work with the data and report. We can generate this data. It's not the system of record, so we need to keep that in mind. So, and usually, another point I want to make here is notice these things: salesperson key, time key, product key. The dimension keys are not to be taken from the source systems. This is something that many people do. It's probably the number one thing I see in warehouses, and it's unfortunate because one of the best ideas in dimensional modeling is this concept called surrogate keys. The idea is if you've worked on dimensional, if you've worked on warehouses, then I could ask you the question, have you ever been burned because the backend system decided to change their data around? And I think you'd say, yes, that's happened X number of times. Well, the idea of creating your own key in the warehouse, the one you own and you do what you want with, is at the heart of the idea in dimensional modeling that you want to take control of that key. So you would use a legacy key. Perhaps you have a general ledger key, for instance, you're going to use to load the data, but you don't want to make that the primary key in your data because that could change. They could say, we're going to get a new general ledger system, and oh yeah, we're going to change all our primary keys around and do a lot of things, and you're in a big problem because your warehouse depends on that key. So instead, you can store the legacy key in your dimension table, but your primary key is going to be usually some sort of like, it could be an identity column or some sort of sequence, and you maintain it, you own it. Nobody can change that key without your permission, without you doing it. And that's a really great thing because, again, it can get us into problems when this happens. The other problem we can get into is when we have multiple source systems, and we'll look at this in a minute. We may have stores that come from one table and stores that come from two different systems. Maybe we merge companies or we have two different systems for doing things, and they may both have the same store number or incompatible key structures. One's alphanumeric, the other one's numeric. By putting it through sort of a mapping process and generating our own key, we can take control and we can consolidate that, and we'll look at that as well. The dimension attributes you define determine the granularity called the grain of the facts. For instance, if you took away, we'll say, the salesperson dimension in this, then the best thing you could do is get total sales by store. And you would typically have to store an aggregated level of information in the fact table because that's the only way you can describe the data, right? So if you try to store individual sales amounts and yet you don't have anything to match that to, then you're going to have many rows for a given store dimension, and you're going to really need to aggregate those to get anything meaningful. So they call the lowest level of detail the grain, but it comes down to typically the lowest level is going to be whatever your systems can support. So if you're getting something from an order system, I like to, for instance, with orders, get down to the individual line items and charges within it, like the tax amount, the item that was bought, things like that, so that it's broken out at the lowest level of detail possible, and I can then aggregate up to whatever I need. But it depends on the circumstances. And again, this is not a relational design, so be very careful. So this table, this slide, is showing us a typical relational table. Nothing fancy here. This would be how very likely a relational table would look. And we can see that we have order number, we have order line number. We see the customer's first name and last name and a sale date and a product and a quantity and price. This is a good way to kind of look at the difference between OLTP versus dimensional modeling. The dimension values come from order number, order line number, the first name, last name, sales date, product. And then when you get to the quantity and price, that would be your facts, right? Those are numeric columns. They measure the event. That's the difference. We would split these off. A good way to start to look at things is anything that's decimal or integer is at least a possibility of being a fact. And anything that's stored as a character is pretty much guaranteed to be a dimension. So you hear things sometimes called a snowflake. Somebody may ask you in an interview. So again, wake up if you're sleeping because this is a question you may get in an interview. What's a snowflake or snowflake schema? And it gets back to, I think the real reason these happen is because we have too many OLTP designers thinking they understand dimensional modeling and building on a transactional approach. And as a result, you get a sort of splintered approach like the one we see here. So we've got fact sales, which points to dim date, and then the month descriptive information like the month name and the quarter and things are split off. We can see the store is split off from the state province, and product actually has two tables, a brand on one side and product category. This would be a great design probably for an OLTP setup. It's a horrible design for a warehouse. Too many crosses, too many joins, and you can imagine even DBA is looking at performance saying, yeah, you got a lot of joins there if you're doing a lot of queries on a lot of your data. But more importantly, it's a lot of navigation and complexity that you just don't need. So we want to typically get away from that, and that's called snowflaking, and generally speaking, it's a bad idea. If you really know what you're doing, there can be examples where you need to Snowflake, but you have to be very conscious of that and avoid it when possible. Some key terms that I want to cover, we've talked a little bit about some of these. One is surrogate keys. So the idea here is an artificially created key, generally an integer. And I'll tell you why, because integers perform well on joins and lookups. Those are good for databases. Use SQL Server or Postgres or one of those, they like integers. They're very efficient. They less space than varchars or whatever you're going to use. That's why I use them. And you can sequence them nicely. So you can just, you need a new value, just generate a new one. You take control though. This is a key that is specific to the database, to the warehouse, and never sent anywhere else. It's only your key to manage your primary key relationships. Next is the grain, which is the level of detail the fact represents. For example, the sales amount of a single item. And as I mentioned, I like to get down to the lowest grain possible. You can aggregate to go into warehouse, but you should be sure if you do that you're never going to need to go back and get lower level detail. Because it would be a pretty rough thing if you designed your entire warehouse to be, say, summary by day, by store, and then suddenly a department comes in and says, well, we really want to know each individual client or customer and what they bought. Or more likely, somebody in accounting says, we have to actually pay a special tax on top of the tax we pay. So we need you to pull out just the tax amounts on products at a product level, because certain categories by law now have to get an extra tax or penalty applied, like a VAR, a value-added tax or something. So that's the reason why getting the lower level grain is really a nice thing, because you can always aggregate and do what you need to do. Whereas if you lock yourself in at a summary level, you can have a lot of work to undo it. Finally, conform dimension. I mentioned a little bit earlier, many times with a warehouse, you're trying to bring a lot of different sources of data together. Maybe you have an order entry system, a general ledger, an accounts payable, maybe even an invoicing system, an HR system, which might have your salespeople and store managers and things. So you've got all these different things, all these different systems trying to merge together. Now, having done this a lot, I can tell you, systems are never perfectly in sync. A lot of times you'll get into issues with timing. The employee was added to HR, but they haven't shown up in security yet. Or worse, there's no human resource. This actually happened where I work somewhere. The human resource system was always lagging behind security records that were supposed to allow them into a warehouse. And you get into these kind of timing issues. So we get errors saying, well, this person doesn't exist. So these are the kind of problems you can hit. And when you're trying to create dimensions for a warehouse, your goal is to create an enterprise-wide view, something that ignores the underlying applications in all these silos and can create a view that you can just see the entire enterprise in one shot. And that's where conform dimensions comes in. It's when we merge all these different conflicting, potentially, sources of, say, stores and employees and salespeople and get it into a sort of a reliable, agreeable source of truth, something we can all agree on. This is an accurate source of truth. And it's something that does not exist necessarily in any of the other systems. Probably doesn't, because we're merging them together. Again, I'll talk a little bit more about surrogate keys. But one of the reasons you want to do surrogate keys, and if you don't, you're going to hit this pretty quickly more than likely, is you're going to need to store history of something called slowly changing dimensions. What happens when a person who was not married is now married, and you want to track that difference? You want to have information before they were married, and you want to have information after they were married. Or maybe you have a store that was in one region and you move it to another region. You want to be able to track sales before that happened, but also when they shift to the other store, the information after that point. To do that, you're going to have to store basically versioning of your data, version of your dimension rows. And you can't do that if your primary key is the same. If your source system said the store code here is X1, and now you've got a different version of X1 you need to implement, well, you can't have two primary keys with the same value. So surrogate keys save us from that. It also insulates us from back-end changes. As I mentioned, if there's changes in the key structure, if there's problems with duplicate keys coming from maybe two different source systems or whatever, we're insulated from that because we're managing the keys on our end. And again, different back-end applications may use different columns as a key. So now let's take a look at the steps of dimensional modeling. first thing we do is choose the business process. What are we going to model? You're not going to try to model the entire enterprise in one time. You'd get into a lot of problems with that. So you need to pick something. Maybe we're going to really try to model sales. It's a good place to start maybe. And once we have that, we're going to declare the grain. What level of detail do we want to try to maintain? And a good place to start might be we'll start with the actual most detail we have, the line item charges of a given sale. Then we identify dimensions. We have stores, we have salespeople, we have a customer, we have products. And those kind of get to the dimensions. And we have facts. We have a sales amount. We have a tax amount. We have perhaps a percentage of interest that we charge if they borrow money. Whatever it is, those are facts. Those are amounts. So choosing the business process. The idea is to pick something that's part of the business and to describe the business process which you're going to be building on. So the idea of choosing the business process is kind of formalized. You want to make a sort of statement of work here almost that say this is what we're going to be modeling. So we choose something and say we're going to be modeling the sales process. And you can use current things like UML or whatever you like to do for doing that. We're going to discuss one approach that I mentioned earlier, the agile approach. Then declare the grain. And this is it's a good idea to try to be formal about this because you want to communicate this to everybody involved, the stakeholders of the warehouse, so everybody's in agreement on what you're doing and you don't find yourself down the road in a disagreement. So in here I have an example, an individual line item on a customer slip from a retail store. It's pretty clear, lowest level of detail. And you need to make sure everybody understands what that is. And then you identify dimensions. Dimensions ultimately have to line up to the level of detail. If you're storing things at a lowest level, then you need to make sure the dimensions match to that. So dimensions are the foundation of the fact table, and it's where the data for the fact table is collected. And these are objects too, typically. So as I mentioned here, it's things like what's the store, who's the salesperson, inventory, etc. And again, you want to make sure you're storing at the lowest level of detail because you may need to access information at that lowest grain level. So you want to be able to do that as well. And then identify the facts. Once you have your dimensions figured out, then you have to figure out what are your facts. And again, typically a quick way to kind of do this if you're converting legacy data from a legacy warehouse or extract tables, a good place to start is just look for numeric values, really, integers and decimals, and then make sure that they actually are amounts and things that are quantifiable. And you want to make sure too that you're getting the facts that people are interested in. If you're getting some value that nobody cares about, then it might not be worth it. So to summarize, you want to choose the business process, declare the grain, identify the dimensions, and identify the facts. And I want to step back for a minute and kind of get a little snapshot of where data warehouses fit in. It almost gets back to the initial question of how they're relevant. So let's take a look at this. In a typical enterprise, what you often find is a warehouse structure much like the picture here. So you can see all these different operational systems which don't really talk to each other or do so poorly. So you've got things like an ERP system, a customer relationship management system, human resources, finance, and the list goes on. Not to mention any number of external sources. I've been in many places, very typical, where invoices and other external documents may be sent in the form of spreadsheets or comma-separated value files, and then we pull those in and we massage them and clean them up, and we bring them into the database. And typically we stage them, and this is kind of the formal process we go to: stage the data, do some cleaning up, and that's part of the extract, transform, load process to bring it in. And then once we get it into the staging areas, that big yellow drum, then we can push it through into the actual warehouse. And in this enterprise data warehouse, what you see is, I believe what this would be is a bunch of different data mods, so kind of different subject areas, and then you can even have areas that combine them into more of an enterprise view. But you get the idea, like lots of different things coming in, and you're trying to make sense of it all and make it all tie together. Again, that's not something that the big data science kind of tools are designed to do. And then once you have that, the warehouse is designed to be consumed in a number of ways. It's a sort of central, very valuable asset to the company that's used for tactical reporting, it's used for business intelligence, it's used for analytics, it's used for forecasting. And you got to remember, you're going to go around and you're going to see that while a lot of people are talking about starting data science projects, this is already in place in most large organizations, if not, even smaller and medium-sized ones, and it's critical to the operation of the business. And I'll take a sideline. I remember one time when I was working at an insurance company, I was working on the warehouse, and when they looked at disaster recovery, I was surprised to learn that the single most important asset that disaster recovery determined that they needed to protect was the warehouse. So it gives you an idea of just how important. That was even over operational systems. I really love this slide. This comes from the Kimball book that I listed earlier. And I love this particular picture because it gives you a nice snapshot of what you're trying to do when you have these dimensions that can come from different sources. So the idea in this slide is this. Dimensions are duplicated across different applications or domains. So retail sales, for instance, a perfect example is date, right? Date is everywhere. So that's going to be occurring everywhere. You might have something like product. Well, product is used in the retail sales. We'll assume that's one system. Retail inventory, that's another system. Retail deliveries, that system. Now imagine if they all had different keys for that. And maybe the information stored, there's a lot of redundancy. And what happens if the inventory has products that sales doesn't? And worse yet, delivery seems to have some products that product and the other two don't. That's where you get into discrepancies, not to mention stores and things like that. So if we look at this, the idea of this, what's called a bus matrix, is to just at the beginning, it's a cursory over analysis. It's probably something you're going to want to sit down with the business and check off where you have overlap. That's really the idea here. Where do we have duplication? So we can see that date and product, and date's really everywhere, so that's kind of redundant or obvious. But product, I wouldn't have known that product necessarily is in every system. And there's where you're going to have some issues if there's any discrepancies between the systems, we'll say. Whereas store is in 3 systems. It's in retail sales, inventory, and deliveries. And that kind of makes sense because they're the retail sales. So when we deal with sales, if we're depending on what we're focusing on, we'll need to understand how to consolidate these different dimensions. So we have 3 different sources of stores. We may have a bit of a challenge consolidating that into a single dimension table. Promotion, we're lucky there. It's only in one place. So that's in sales. We should be pretty safe there. Now let's assume we're really just focused on sales. Then we can take the last 3 rows and exclude that for now. It's like kind of, whew, we don't have to worry about warehouse, vendors, contracts, shippers. Not an issue. So again, this kind of bus matrix is, and I think buses really should be biz matrix, I guess, because it's business matrix. But it's a nice way to get a snapshot, and it's very something you can use to communicate to other people, stakeholders, to make sure we're all on the same page. Again, that consolidation of these dimensions is one of the big challenges in warehousing. So now the big question, how do I determine what my dimensions and facts are? I've alluded to it a bit, but haven't really given you a complete answer. So let's delve into that. So this is where the book on Agile Data Warehouse Design comes in by Lawrence Core, and I've got the note at the bottom trying to credit Lawrence's book. I really like this because once you get to the point you get a concept, you want to say, well, how do I approach the business? This approach of doing an a dimensional model is particularly relevant if you're in a business that you're not that familiar with. If you've been working for years, you're a domain expert in a particular business, you may not need to do this as much, but still you're going to want to spot check what you're doing with the business. But let's assume, you're relatively new, you stepped in, you're starting to work for, some company, and what you do is you create what's called a user story, and you're just basically trying to narrate an event that is a standard, typical event in the domain that you're interested in modeling. So we talked about sales. So here's the idea of a person purchasing a product. So we get Mary Jones buys one book for $22.50 entitled Agile Data Warehouse Design on December 2nd, 2013 at 3:12 p.m. via Amazon.com using her Visa card, and is to be delivered on December 10th, 2013 by UPS. So that's the story, and I think it's very intuitive. What's nice about this is if you were to present this kind of approach to the business, they're not going to freak out and say, oh my God, I can't look at these diagrams. You're using too much jargon. This is so approachable by anybody in an organization that it makes it really easy to discuss things. And I'm going to discuss it more, but what's really going on in this slide is what the book calls the 7 W's of data warehouse design. Now, truthfully, there's two H's in here, but who's counting, right? But the idea here is how, what, when, where, who, how many, and why. Most of these are dimension questions, but this is how we can answer what's a fact. When you're answering the question how many or how much, that's a fact. All of the other ones are dimensions. So let's take a look at our little user story there. Mary Jones is who, so that's dimension. The what is a book. How much, 2250. And we got Agile Data Warehouse Design. So the book title itself is a dimension. When, that's a date, that's a dimension. On Amazon.com, so that's where, and that's a dimension. How she did it, Visa card. So the only fact in this entire user case story is the amount, how much. Everything else is dimension, and we can get a feel for what our dimensions are. We can now say we're going to need a dimension about a customer, right? We see Mary Jones, so we obviously need a customer. We also need some sort of product. We see we have books, we probably have other products, right? We have a title, so we're probably going to have books and book titles. So just from looking at this very simple example, we can infer a great deal about our dimensional model without even looking at source data or anything at this point. So try another example. Imagine you kind of, I used a spreadsheet when I was applying this in an actual case, and I just wrote a bunch of different ones, and it led to a lot of nice discussions. So the next one I wrote was Boston University, and it was kind of a test. Do organizations order things, or is it always a person? So I was kind of testing, will the business come back and say, oh, well, we can't have an organization order, it has to be a single person. But in this case, organizations apparently can have accounts, group accounts, which is another thing you'll have to factor into your model. Orders what? Books. How much? This isn't quite a line, apologize for that. How much? $10,000 worth. Using a corporate Amazon account membership. So we see that there's a different thing than your typical Visa and things. There's account memberships, and there's a discount, and there's of Amazon Credit Finance. So apparently Amazon has its own credit system that we're going to be tracking, and the percent of interest. So we've learned of a new fact we hadn't seen before, interest, and we've learned some new dimensions, and we've learned that we not only have this concept of a single individual, but also this sort of organizational customer. So what is nice about this approach using the user stories, is it's intuitive and natural for business users. It's an efficient way to get to the details. After a handful of stories, you get a pretty good idea of what you need, and you want to draw to the business, let them participate, because they'll say, well, yeah, but you also need to know, what kind of shoes they wore, because we track that, or we need to know where they're from. We need to know whatever. And as they talk, the business will become more comfortable, and they'll start revealing a lot more of things they're probably assuming that everybody knows and will just include in a data warehouse, and won't be surprised if they reveal it when you're doing this, because they otherwise may not get it. It provides a really good jumping off point, as I mentioned, so people can participate. And you can kind of, what I like too is, very often when you're trying to do anything with IT and you get into requirements, people get nervous and they start jumping all over the map. Oh, let's talk about this, and you run down these rat holes where you're discussing details about something that's really tangential to your process. But when you use these user stories, it's kind of nice because it can keep you focused. So now the big question. What happens when dimension values change? And they can change. So let's take a look at that. So dimension values can change, and how the change is handled is going to depend on what the business wants to do. This is definitely one of those cases where you need to push it back to the business, but you also have to be very cautious and critical of the answer you get back, because sometimes the business will underestimate, they don't realize the impact of the decision they're making. This is one of those cases where it could be a lot of work if they change it later. So let's assume something. So the New York store, we'll assume it's an organization, and we're talking about sales again. The New York store is reassigned from the Northeast region to, we'll say, the middle region. Does management want to be able to see the changes in sale as the Northeast region before and then as the middle region after? So if you need that, then you're going to have to track all sales matched up to putting that store in the Northeast region first, and then after the date changed, now data needs to go into the other region. And that's what we call slowly changing dimensions. They're not always that slowly changing, but the idea is you don't want this to be happening every day, but certain things will occasionally change, and it can be important to the business. So this is also almost guaranteed to be on your, if you're getting a data warehouse interview, they love to ask this question. And frankly, it can get confusing between type 1, type 2, type 3, but try to go through this with me and try to remember it, because they often do ask this. But I think the more important thing is less the type number, and the choices we have. I'm only covering 3, but I've seen up to 5 and even more depending on different ways you can mix and match these things. So the simplest one, the one that essentially really isn't handling it all but makes it look good, is you can say you're doing a type 1 and people think you've really thought this out. And the idea of a type 1 is simply you ignore the fact that it's changed and you just overlay, you just update. So unfortunately in that case, in the case of the New York store, as far as you're concerned, all of the sales ever done was in the mid region. You've lost the idea that they were ever in the Northeast region because you're not tracking that, you just update it in place. If you're not doing data warehousing, you don't have much choice to this, and I've seen some heavy-duty jury rigging to track history without the advantage of dimensional modeling. So the disadvantage obviously was lose the history. But what other choices do we have? We can do type 2. This is the most work, but the most advantages as well. You keep all historical values. So you basically, we've done versioning of source code, right? We take snapshots. The idea of type 2 is you version it. You say, okay, as of from the beginning of time, we'll say to this date, this store was in the Northeast region, and then you have like an end date, and it's no longer the active value. And from this date forward, it's now in the mid region. And if it changes again and moves to the south region or whatever, you can then end date that one and move it to the next one and keep moving. And so at any point in time, you can look at sales and roll them up to the proper region they go to, even though the store moved around. So it dynamically adjusts the data because it's got versions of that store dimension. And type 3 is a little bit easier to implement, but I'm not a huge fan of it. I've never actually seen it implemented. I think it would have to be a very narrow use case personally, but the idea is you just provide some support of the dimensional history. You would basically just keep the current value and the last value. Not a big fan because you don't know if you were to do this. It works for the first use case. You can now say this store was in the Northeast region and now it's in the mid region, but if it were to move back to the Northeast region, you would lose the fact that it had switched between these, or if it went to the South region or somewhere else. So I think the value of that is very limited. It's also a bit awkward, I think, to manage. If you with the normal slowly type dimension type 3, you actually have a more consistent, I think, way to manage it. This way you're kind of storing an extra column to track the last value and the current value. And you can track several values if you want. The case where I might agree that it would make sense if you're looking at something that is typically a really one-time event. Not sure what I might say there, but it could be something like living versus non-living. That might be something where, well, once you've hit that event, then you probably aren't going to go back, and that might be a valid use case for type 3. But I have never really seen many situations where you would use that. Again, this is something where you really need to go back to the business and get their feedback on it, and then be very cautious of their feedback, because very often the business just wants to get something in faster, and they realize that if they ask for it, it'll take longer. And then you'll get it in and they'll say, we really need to know the whole history of the store or the customer. We need to know where that customer has lived at different points in time, because that makes a big difference in how we promote a product. So really be careful about that. One of the nice features in a warehouse, and even if you did nothing with dimensional modeling, I've actually used this at a client, just giving them a date dimension. What a date dimension does is when you get a date, if you've ever had to do reporting and you get, say, sales dates, and you want to break it out and group it, say, by month, and then maybe by quarter, and maybe even like year and things like that. And maybe you want to do it not just by fiscal, but maybe you want to do it by some other type of calendar. The nice thing is, if you use a date dimension, it's just a lookup table, really. It's a dimension that you can join to, and it has all these other attributes, and it's just using the date column to do this. So without having to do all these functions and parsing and trying to generate months and quarters and things, it's just a table, and you can summarize and aggregate and everything. So it's a very useful thing. SSAS actually has a wizard that will generate it, but I've just gone online. If you search online for it, you can find different examples of these types of tables, and it's just a row for every possible date, because if you think about it, you only have 365 individual dates in a year, so it's pretty easy to create 20-30 years worth of these dates, and now you have a nice easy way to map them out to quarters and whatever you need. So I highly recommend creating a date dimension. So some additional thoughts. One of the things that I hit when I first got into dimensional modeling, and this was back when cubes were the big hot thing as opposed to the new tabular model for SQL Server, is this idea of a star schema, is that just conceptual, or are you supposed to physically implement it? Well, I'll tell you what I did myself. I tried to jump past that and do a sort of prototype. And I implemented it based on views that simulated dimensions and facts, and then I built a cube off those views. So it's basically a kind of proof of concept, but you got to be really wary of that, because then the business took it and ran with it. And I was kind of like trying to say, no, it's just to see that this works. But they were so happy to get something, they didn't care really about that. They didn't understand the implications of not having a true star schema. So the answer is yes. Now that cubes are not the only thing around, we can see better that the data warehouse is really a baseline. It's a resource upon which we build our reporting assets. So yes, we do implement the star schema, and we avoid the Snowflake schema if at all possible. And again, what's the difference between a dimensional model and a cube? I think that's a less relevant question. And we see now we have the tabular models I mentioned. But the idea is the warehouse is the source of data, and everything else is consuming the data. All right, so to review what we've talked about, I know we've covered a lot. We've discussed dimensional modeling and warehouses. Do we need warehouses? Dimensional modeling is still relevant. And we looked at, I think we've confirmed we do need it in the right situations. We discussed dimensional modeling and the idea that we're really going to segregate out things that describe an event, like dates and times and stores and people's names. Excuse me. Pretty much anything that's an object, versus the dimensions, versus the facts, which are just the metrics. And we looked at things like key terms like surrogate key, grain, conform dimension, and bus matrix. And that's all part of the whole thing. And the surrogate key was a key thing. It's because as a warehouse, we take over ownership of the key. We looked at the star schema. And if you're in interviews, be very big and positive about the star schema, because that's what people usually want you to say. It's awesome. And you want to be very down on the snowflaking, because it's typically not a good thing. It's frowned upon by Kimball. We looked at slowly changing dimensions, and one of the nice things, again, when we get to using surrogate keys, is that slowly changing dimensions allow us to, basically as a way of tracking history, but we need surrogate keys to really do that. And the whole approach here of using dimensional modeling lends itself very nicely to slowly changing dimensions. And then we looked at the date dimension. And there's a thing in there I didn't mention called role-playing dimensions, because one of the things with dates is we have many different dates. So usually you have things like a product code, and we just have a product dimension. You have a store dimension. But dates are a really odd entity. You have a date, but you have a purchase date, you have an open date, you have a close date, you have a person's birth date, you have any number of things, many dates. And so you map them all typically to the same date dimension, but you call it a role-playing dimension when you're connecting to it, because you've got many links to the same dimension. And they all really are different meanings, but the same format is essentially a date. Well, I've hoped you've enjoyed this presentation. I hope you've gotten something out of it. Feel free to leave comments, email, contact, follow me on Twitter, and please subscribe. I'm going to be doing more training, and this is just a little bit of a new direction because I want to get back to some of the basics in data platform and architecture, and this was a good place to begin, I think.